solve negative 2 absolute value x plus 1 greater than 3x plus 8, okay? Have you seen something like this before in class or recently?
Yeah.
All right, do you any idea how to start here? Notice there's variables on both sides of the equation here.
Yeah. Would you subtract 3?
You could do that, and one reason you can do that is your goal is to move everything to one side or the other. This negative 2 is multiplying the x plus 1. It's probably better to distribute that first. Now you will eventually move the 3x over here. Can you tell me the result from distributing something like this?
Negative 2x minus 2.
Good. All right. Now again, that same question here. Now your answer's correct. Minus 3x minus 3x minus 5x minus 2 greater than positive 8. Okay.
Mhm.
So go ahead and tell me what you might do next here to solve for x.
Add 2 to both sides.
Add 2 to both sides. Good. So this leaves minus 5x greater than 10. Okay. So we're almost there. We almost have x by itself. What is keeping x from being the only thing on the left side of the there?
The 10.
What about we're looking at the side with the x, just the side with the x. What do you see over there on the left? What is multiplying the x there?
The negative 5.
Yes, so you undo that with division. So you're going to divide both sides by negative 5. Now you should sort of say, okay, I've got to do something when I divide by a negative. Do you remember that from class?
You're going to flip the sign.
Yes, so x is less than negative 2.
Negative 2. Okay.
All right, so let me give you one to try here like this one. Any questions on this?
No.
Okay, so let's try minus 4 x minus 2 plus, sorry, greater than, let's go 2x. Sorry, just trying to make sure the numbers work here. Plus 20. Let's try that. All right, go ahead and try that, and let me know if you have any questions. Just kind of getting refreshed on this.
Would it be x is greater than 7?
So I know that there's potentially a problem here because you've not flipped the inequality. So I'm not sure though. Like I haven't worked this out. I only sort of thought the numbers would work out nicely. Did you distribute the negative 4 to both terms?
Yeah.
All right, so that's negative 4x plus 8. Is that what you have written?
Mm-hmm.
And then you got 2x plus 20. subtract 2x, subtract 2x. So maybe that's the issue. Maybe didn't get this done. This is minus 6x plus 8. Is that perhaps
Yeah.
the issue? Okay. So in terms of this, just as a reminder here, it's like you owe someone $4, you owe someone $2, you now owe them $6. Okay. Do you want to try working it out from here?
Mhm. X is greater than 2.
Okay, so might be correct here. Again, I'm concerned though because you've not flipped the inequality. So you subtract 8 from both sides, minus 6x greater than 12. Now you don't flip the inequality here. It's only when you multiply or divide by a negative. Now on the left here, you divide by negative 6. X is now less than negative 2.
Oh, okay.
Where do you think what's the difference between your work and mine, or where do you?
I forgot to add the negative sign for the 6.
Okay, so you treat it like it's together. Negative 6 versus 6, very different. Owing versus receiving, important there. Okay, now a new question for you here: is negative 3 less than negative 2? Is this true or is this false? And if you're not sure, try graphing a number line. Think about where those numbers would fall on the number line.
Yes.
Okay, so the way you answer this is really, it's like, is negative 3 to the left of negative 2? And you are correct. It is to the left, negative 2. Okay, so let's try a couple more problems here. This negative stuff really, it really does seem to be very challenging. So let's just do a few more problems here. Let's say it's 6x minus 3 less than 8x plus 5. Okay, something like this here. Right. Now you have a choice when you're solving this. Like, you do not have to always move the variables to the left. Now I know that's probably the preference, and it does work most of the time, but you could move the variables to the right. The rule, kind of, if you if you want to know like what would be taught, is you generally move from the smaller to the larger. So in this case, you would subtract 6x from both sides. The problem is that we don't like when the variables are on the right. Okay, so you literally do have a choice here. Like, is this look better to you, or do you prefer to move the variables left?
Probably left.
Yeah, and we're just going to do that for today. We're just going to move all the variables left. Keep going here. So it's minus 2x minus 3 less than 5. What's the next step to solve this one here?
Add 3 to both sides.
Add 3 to both sides, yeah. So now this becomes negative 2x less than 8. What will you divide both sides by?
2x. Negative 2.
The number in front of x, yeah, negative 2, good. That flips the inequality, and it becomes negative 4.
Okay.
Okay, now new question for you. Is negative 5 greater than negative 4? And if you're not sure, you really want to confirm your answer, always good to draw a number line there.
No.
So this is false, yeah. So -4 is here, -5 is here. -5 is actually less than -4. All right, so let's have you try another one here. Let's go minus 3x minus 11 less than -5x plus 19. Okay, so this time when you move to the left, the variable, in this case, the 5 minus 5x, you have to add it, which is different than the previous problems. So this sometimes it works out nicely when you move it left. In this case, 2x minus 11 less than 19. Okay, do you want to try solving this one from here for us, please?
Sure. X is less than 15.
X is less than 15. Good. Okay, any questions on that before we move on to something else?
No.
All right. Okay, so let's talk about the between problems. Okay, so between inequalities, this is when you're generally going to see two inequality symbols. So it might be something like this, like -4 less than 2x minus 3 less than or equal to 5, we'll just say. All right. Have you seen some problems like this in class?
Yeah.
Okay. So what's different or odd about this is you're still trying to isolate x, but x is bounded between these two symbols here. Okay. Now some students like to kind of break these apart. I think it's better just to work on them right here in the middle. Okay. And we're kind of used to this idea of that there being two sides of an equation. In this problem, you almost look at it like there's three sides, because there's the side on the left here, the side in the middle, and the side on the right. Right. Your goal is to still isolate x, so you want to undo anything that keeps x from being by itself in here.
Subtract 3 from both sides?
If it were
Or
added,
add
yeah,
3 though?
yes. Okay. So this leaves us with -1 less than 2x less than or equal to 8. How do you undo division by 2? Or
Multiply?
multiplication, I'm sorry, multiplication by 2. I just answered it. Divide by,
Division.
yeah, whoops. All right. Now, this is the first time we've seen like something that doesn't work out nicely. And you should be okay with that. You should say, okay, I'm okay that I might get some fractions here. Okay. Sometimes it works out that they're both fractions, one's a fraction, none are fractions, but don't let that like be discouraging. Just go with it. Okay. All right, so now a new question here for you is x equals 3 a solution? And what I'm really asking is x between -1/2 and 4?
Yes.
It is, so this works. Now in a number line here, here's -1/2, here's 4. Is it an open or a closed circle on the left there?
Open?
It's open. And how about on the right at 4?
Close.
Very good. And then you're going to shade between the two. Okay. Any questions on sort of how to work through a problem like this before I give you one to try? That'll be very similar, just different numbers.
No.
Okay. All right, let's go 5x minus 4. between 16 and -14. Go ahead and try this one. Let me know if you have any questions. And
Okay. Would it be -2 is greater than or equal to x, which is less than 4, or would you keep going?
like this,
Yeah. Or would you
that
keep going?
when you say keep going, what do you mean by that? Because this is looking pretty good, and I'm just curious what you mean by that.
Oh, never mind. Sorry. I thought I was
Go ahead
looking
and yeah,
right above it, and
go ahead and finish your thought, because you at some point divided by 5 here to get each of these numbers.
mhm.
Okay. When x is alone, now what does that really mean? It means it's the only thing between these two inequalities.
Okay.
Okay, and it is. So this is your final answer. Okay. Is x equals -3 a solution?
No.
No, it is not. Okay, so let me give you some more difficult problems here for us to look at. Let's go -3 less than or equal to 2x plus 1 divided by 6 less than go +9, like that. Okay. Now, I don't know if we've looked at one like this here, but there's more stuff keeping the inside from being alone. Okay, it's more complicated. You wanna write these parentheses, even though they're not generally written in the problem. They're called implied parentheses, which means that they're there, they're just not written, so you might as well write them. This division by 6 takes precedent because this is really in parentheses. When you're solving, you undo um, stuff that's addition, subtraction, then multiplication, division. So we're going to undo division by 6 here. To do that, you multiply everything by 6. Okay. So on the left here becomes -18 because you're multiplying. In the middle, the 6 drops out. And on the right, you get 54 here. Now we're going to subtract 1 all 3 places. -19 less than or equal to 2x less than 55. And last step here is to divide by 2. Divide everything by 2. So notice that they're both fractions this time. They don't divide out nicely. You could write, like if you really wanted to, you write minus 9.5. On the right here, you could write 27.5. You don't have to though. You can leave it as a
Fraction.
fraction. It's up to you, or whatever your
Okay.
teacher wants. They're grading you. Let's do what they want to get maximum benefit on that. Okay, so here's one for you to try. Let's go 3x minus 2 over 4. Let's do less than or equal to -2, less than or equal to +1. Let's go ahead and try working this one out. May not work out nicely, but at least see where you're at working this out.
-2 is less than or equal to x, which is less than 2. So
Like
x
the
between -2 and 2.
like this on the right?
Yeah.
Okay, tell me what you did first. What's the first thing that you did here?
Multiplied everything by 4.
By 4. Okay, like that. So the on the left here, it's -8, less than or equal to 3x minus 2, less than or equal to 4. Then what did you do?
Added 2 to all sides.
Okay, looking good. -6 less than or equal to 3x, less than or equal to 6, and then you divide both sides by 3. So sometimes they work out really nicely. Who knew? All right, so now we're going to work on an exception. So kind of a weird kind of thing that you might see in one of these problems. Here's one. So -31 less than minus 10x minus 1 less than 39. Okay. So here you're going to do the same thing we've been doing. We're going to undo anything in the middle to get x alone. So that starts out by adding 1, adding 1. -30 less than minus 10x less than 40. What do we divide everything by in this step?
10?
What is the number in front of x though?
-10.
So you should divide by -10. And whenever you divide by a negative or multiply by a negative, you flip
Put the
the
sign.
the inequality. So this is your answer, okay? And I don't know, the joke, I don't think you don't have to laugh, but it's like you can put a shirt on backwards and you still have a shirt on. This is correct. It's just not, you wouldn't want to present it this way. Like, and the reason is you always want the smallest number on the left, the largest number on the right.
So would you just flip them?
You flip it, but you have to be careful here. See how this is pointing at the number on the right here? It still has to be pointing at the number. This is pointing at x, so it's pointing at x. And that's my preference. I prefer to say like it's pointing, even though you don't want to point your finger or anything. You don't want to be, that's, you know, bad, I don't know, what's the word? Anyway, so you do have to make this adjustment. Like this is right, but it's not preferred. You need to do it in the full on way down here.
Okay.
Okay. So if you understood that, and I'll just add in a little wrinkle here. It's not just x. Like I've been using x all the time. It doesn't have to be x. Here's one for you to try on your own. Go ahead and take a look at that and let me know what you come up with.
N is between 0 and -9.
So like this.
Yeah, but wouldn't you do it the other way though?
Well, you've got to decide which one is smaller. Okay. And so let's work.
-9.
Well, let's work it. Yeah, let's work this one out together. Did you add 2 to everything?
Yeah.
Okay. So right now it's 0 less than or equal to minus 3n less than 27. What did you divide everything by?
-3.
Okay, very good. Now that switches everything, the inequalities. What is 0 divided by -3?
-9.
0? 0 divided by?
Oh, wait, sorry, 0.
0. On the left, yeah, on the right, it's -9. Okay. I heard something else. So you said something else. I mean, the good thing is math's not a written or an oral exam. It's a written. Which is smaller, 0 or -9?
-9.
So -9 goes on the left. This thing is pointing at -9, so it's got to still point at -9. 0, and then this is pointing at the end, so it's got to be pointing at the end.
Mhm.
Any questions on that?
No.
Okay. So if you try another one here, let's go -4 less than or equal to minus 3x plus 2 less than or equal to 17.
X is between -2 and 5.
Okay, so one of the problems with the way you're saying that is I don't know if you mean this symbol or this symbol or this symbol or this symbol. So do you want to give me the number first? Say the give me the number that's on the left here.
-2.
Okay, and then what goes here? Is it less than or equal to?
Less than or equal to
Okay,
X, which is less than or equal to 5.
yeah, and I may be contradicting something I said in a previous lesson, like um, because we need to know whether it's a less than or equal to or less than or equal to or less than. You kind of just read it left to right here. Okay, this looks pretty good. Let me just work it out here. So you subtract 2, subtract 2, subtract 2. -6 less than or equal to minus 3x less than or equal to 15 divided by -3. So that's 2 less than or equal to x less than or equal to -5. But I got to flip those. Almost didn't do that. So I've got different signs than you. So did you write 2 and -5, or did you write -2 and +5?
-2 and +5.
Okay. So the when you divide by the negatives there on the left, -6 divided by -3, that's 2. 15 divided by -3 is -5 there.
It's because I forgot to carry down the negative sign in front of the 3x, so.
Yeah, so it's just small stuff like that means the difference, between certain scores in the tests, and it doesn't mean you don't understand it. It just means that you just have to be very, very careful. Okay, any questions on that before we move on to something else that's kind of related?
No.
Okay. So sometimes these are referred to as and problems that we've just been doing, the compound ones, and sometimes they're literally written as that. And I'll grab one here for us to look at. So they sometimes actually literally put the word and in the problem here. All right. And to solve these, you work them out just like you've always done. You just work them out separately. You just work on the one on the left and you work on the one on the right here. Okay. So go ahead and solve the one on the left for me, please. And let me know what you come up with.
Um, I don't know what to do first.
All right, how about let's just add one to both sides. Okay, so on the side with the variable, which I'm going to box in here, you've got subtraction by 1 and multiplication by 5. Now, if you're wondering, like, what about that plus? That's the operator between them. It's still 5 times the n. It's not adding 5. It's 5 times n.
Okay.
So this becomes 5n greater than minus 25.
Would it would it would it be n equals -5?
The greater than has to carry you through the entire problem.
How did I forget this?
It's okay. It's this is practice. Have you ever done yoga before?
Yeah.
You know, and they constantly talk in yoga. They're like, "This is practice. You're practicing, right?" And I always ask myself, "What am I practicing for when I do yoga?" But that's a side issue. You're practicing for the test. Like, it is okay to make mistakes now. Okay, we're practicing for this future thing where you want to get a good score. So don't be too harsh on yourself. The inequality carries all the way through. It only flips if you multiply or divide by a negative. And in this case, you have not. So n is greater than -5.
Okay. I got that once I like carried over the sign, but I just forgot it.
Well, chance to redeem yourself. Go ahead and see if you can work out the right-hand side, please.
Could we write it as n is greater than or equal to, or yeah, greater than or equal to 5 over -2?
You're working on this one on the right, correct?
Yeah.
What did you undo first? Subtraction by 2 or multiplication by 7?
I
Or,
didn't do that.
or neither? So your focus is always on the side with the variable. Like if I was there, in person, and I used to do this, I would put a sticky note on the right hand side. Like, you don't care about the right hand side, or cover it up with your hand. You don't care about the right hand side. You only care about the side with the variable, and you focus on that. You say, all right, I got to get rid of this -2. I got to get rid of this division or multiplication by 7. So add 2 to both sides. 7n less than or equal to 14. Is that okay?
Mhm.
Now you're going to divide by 7. N is less than or equal to 2.
Yeah.
Now, very important here, this keyword, this word that we had from the beginning, and you have to write it down here at the end of the problem. So n has to be greater than -5 and n is less than 2. So sometimes it's better to just do this graphically. Here's -5 and here's 2. So n greater than -5 means going to the right forever. Do you agree with that?
Uh,
N greater than -5. All the numbers bigger than -5.
yeah.
Okay. I sense some hesitation there. We'll try to address that here. N less than or equal to 2, that means start at 2 and go to the left forever.
No.
So you're not liking these inequalities.
Mm-mm.
Okay, we need to address that because that's an important part of this. Okay, x is greater than 6. Okay, this means in words all the numbers right of 6 on the number line. And you previously, I would give you a problem like this. I would ask you, is this true or false? Is 7 greater than 6? And you would tell me that this is true. I might ask you, is 8 greater than 6? And you would say true. But then I might ask, well, is 5 greater than 6? And you would say,
No.
no, it's not true. Now let's look at this on a number line. Let's say 6 is right there. 7 is good, 8 is good, but 5 is not good. So x greater than 6, because it's greater than means larger than. It also means to the right of. It means all the numbers to the right of 6. So when you see something like x greater than a number, you go to that number and you shade to the right.
Okay.
It also works going the other direction. So let's say, and we've done this before, let's say x is less than 4. Okay. Is 3 less than 4?
Yeah.
Yes. How about 2? Is 2 less than 4?
Yeah.
But 5, is 5 less than 4?
No.
No. So we go to our number line again. Like, okay, let's look at that. Here's 4.
Everything to the left of 4.
Exactly. Exactly. All numbers to the left of 4. Okay, so it doesn't matter what the number is. Like if it's x less than -8, we'll just do that here. If it's x less than -8, it means all the numbers to the left of -8. X greater than -4 means right of -4.
So if we were to put that as the point, which one would be the parenthesis and which one would have like the bracket around it?
Yeah, it's a good question here. So there's kind of a mapping here. If you see any of these symbols, it's parentheses. If you see a
Okay.
less than or equal to, a greater than or equal to, a filled in bubble, these become brackets.
Okay.
That maybe that clarifies something that was unclear for a while. Okay, so we were working on a problem where the result was n greater than -5 and n less than or equal to 2. I was trying to show you on a number line, the graphing of these. So here's -5. So that means all the numbers to the right of -5. And then the other one is at 2, and it's all the numbers to the left of 2.
Okay.
So the this is not the answer. There's a bit more to do. You have to like figure out where the overlap is. Where is the overlap?
From
Okay,
-5 to 2?
that's right. Now at -5, and here's x or n, I guess it's n. Is it a less than or equal to here? Is it this symbol or this symbol at -5? And it's based on whether it's open or closed there.
Less than?
Yes. And then same question here at 2, is it this one or is it this one?
Less than or equal to?
Yes. Okay, so let's do an exercise here, a couple of exercises. Let's say I give you a number line where it's let me clear this out so you don't have a reference. -3 and 4, and let's say it's like this. And let's say the variable is t this time. So I want you to write the inequality that goes in here.
-3 is less than t, which is less than or equal to 4.
So it's just less than 4 because it's an open circle on both of them.
Oh.
All right, let's do another one here. Let's do number line. Here's -7, and we'll go to the right. Here is +1, and we'll go to the left. Give me the inequality where they're both true. The overlap.
-7 is less than or equal to +1.
Oh, I didn't give you a variable, so let's call it x. So what's the inequality that goes here?
X.
We got the x. What's the symbol? Is it this one or this one?
The first one.
Yes. Very good. All right. Well, that's going to take us to the end of our lesson for today. Good job.